Welcome back, trigonometry students who happen to be in the course called pre-calculus. We kind of got to think back to our functions for a while. We had functions which quote-unquote undid one another. What I meant by it was if we took f of x and we were to apply this function g of x, we had a special name for what happened when we were left with just x. Those functions were called inverses. Trigonometric functions have inverses as well. We're going to study them at depth, ad nauseum a little bit later, but right now we're only going to look at one. This one's going to be the inverse of sine. How we refer to the sine inverse is one of two ways. The function that undoes sine is sine inverse of x, or another way you can write it is arc sine. Either one's acceptable. Here's the relationship for the domain and range of sine and the sine inverse. So when we have some function that is the sine of x, what it's asking for, or let's actually make the sine of theta, what we're starting with are angles. We're saying, hey, when we have an angle, when we have pi over 4, when we have 33 degrees, when we take the sine of it, what that's coming up with is a side length ratio. What arc sine, or what sine inverse does, is say, hey, let's start with this side length ratio. We know that the ratio is 4/5. We know that the ratio is 0.88. What angle is going to get kicked out? What angle creates this side length ratio? So for sine, we start with the angle, we get a ratio. For arc sine, we start with the ratio, and we get a sine. And just like that, these are inverses. Remember, these are inverses. They undo each other. So if I have the sine of some theta, and I take the sine inverse of that, just like g of f of x leaves me only x, the sine inverse of the sine of theta leaves me with just theta. These are both kind of conceptual understandings that can help us solve following right triangles when we've been given nothing but side lengths. To start with this, one of the easiest ways is to get the side length. In this case, we're going to use Pythagorean theorem to help come up with the hypotenuse. We can say c squared equals 16 squared plus 8 squared. I didn't solve this beforehand, so we're going to use a calculator. 16 squared plus 8 squared gives us 320. C squared equals 320, which means C equals the second square root of 320. 17.89, about 17.89. You can round it. I'm going to leave it as a square root of 320, just so when I type things in I get nice precise answers. But let's say we need to find one angle. I don't know, let's call this angle A. And we want to find angle A. What we're going to do is set up the sine relationship for angle A. The sine of A equals, well, what's the side opposite of the sine of A? Sine opposite of hypotenuse, side opposite of that is 16 over hypotenuse we just found to be the square root of 320. So we're left with the sine of A equals 16 over 320. What we're trying to do is isolate the A. If we think of this as a function, what we're going to try to do is get rid of the sine inverse by applying, get rid of sine by applying sine inverse. We're not multiplying, by the way, we are applying the function. It kind of sounds weird. A lot of times students will say, hey, multiply by sine inverse. No, we're not multiplying by sine inverse. We're taking the sine inverse. The other way to think of it is saying, if the sine of A equals 16 over the square root of 320, what angle will give me that ratio? Either way, what we're left with is A equals the sine inverse of 16 over the square root of 320. We can type that into our calculator. I'll hit second sine inverse of 16 divided by, I got the square root of 320 as my answer, so I can hit second ans. And it'll come up to 19 we'll say 6. That means that our angle is 19.6 degrees. Once I've got that, I can have that come up with my other solution by taking 180 minus 90 gives me 90. 90 minus 19.6 is going to give me 70.4 degrees. At that point, I have my triangle solved, and I'm done with the problem.